Thank you, Brian. This is the last talk of the today omics symposium. So I'm gonna talk about some of the multi-omics analysis result on the chicken meat quality alterations found in the chicken spaghetti meat conditions. So I'm gonna talk about briefly about the characteristics of the spaghetti meat first, and then talk a little bit more about result of the omics data, and summary and future directions will follow. So Benham is already talked about some of the woody breast and white striping, but I expected he also described some of the spaghetti meat already, but he didn't. So I'll just briefly describe a little bit about the spaghetti meat characteristics. So spaghetti meat is a relatively recent chicken breast myopathies, and which was first detected in 2015. And then spaghetti meat is characterized by muscle fiber separation of the chicken breast muscles, representing spaghetti noodle-like muscle fiber bundles. As you can see in this slide, this slide shows there is some phenotypic characteristics of the white striping wooden breast and spaghetti meat. I'm not going to talk white striping and wooden breast, but spaghetti meat, as you can see that in the histology result, this histology result show that there is a lot higher contents of the connective tissues. So this spaghetti meat, the overall spaghetti meat shows the overall impaired muscle integrity and stringy with the soft consistency at the ventral cranial portion of the breast fillet. And spaghetti meat may be caused by the poor cohesion of the muscular fiber bundles. And also spaghetti meat is known to be caused by mechanical stresses at the processing plant, which may weaken the scaffold. And I think this is also very important and interesting observations for the spaghetti meat instance. But still, there are some intrinsic susceptibility of the spaghetti meat instance. So spaghetti meat fillet may retain some kind of the signatures expressing altered muscle fiber bundle integrity compared to the normal fillets. So those signatures may be the mRNA, protein, metabolites, or the lipid species. In contrast to the extensive study of the omics study on woody breast and white striping, there are few omics study on the spaghetti meat has been published. So you can see that the two omics study has been published this year, one in the transcriptomics on the spaghetti meat and woody breast, and the other one was a metabolomics study with the spaghetti meat. And then two independent omics study has been conducted in our research unit, USDA ARS. One study was a metabolomics, the other one is a multi-omics analysis. So let's briefly review about those various omics result on the spaghetti meat. So one transcriptomics result has been published earlier this year from University of Guelph. And then in this study, they used the woody breast condition and spaghetti meat conditions. So in this study, muscle samples were collected at the processing plant, and RAS 708 broiler, 37-day-old male chickens were used, and then samples were procured within 3 hours post-slaughter. So after 3 hours, they collected samples. And each 10 samples were collected from severely affected area for spaghetti meat and woody breast. And then normal fillet was collected from the cranial and superficial areas. And then RNA sequencing was conducted. And as a result, they found 4,018 differentially expressed genes, including 2,770 up and then 1,248 downregulated on the false discovery rate less than 0.01 and fold change 1.5, greater than 1.5 in spaghetti meat. And as you can see here, so there are some the phenotype and then the data processing, and there is a biological pathway analysis. And then here is some of the interesting result of this transcriptomics data. You can see that in here is about 2,300 differentially expressed genes identified from the woody breast meat was overlapped with differentially expressed genes identified from spaghetti meat. This table shows that it's the representative up and down regulated genes, and then you can see that in the both fold change values were the same trends in woody breast and spaghetti meat. So the feature of spaghetti meat and woody breast share common transcriptomics profiles, indicate that the spaghetti meat may retain similar physiological alterations to the woody breast condition. Additionally, the collagen subtype expression also similar trends in the woody breast and white striping. And then the pathway analysis showed that in the cytokine receptor interaction and neuroactive ligand receptor interaction, alteration on these pathways were found in spaghetti meat and woody breast at the same time. But interestingly, calcium signaling pathway alteration in this pathway was found in only woody breast, not in the spaghetti meat conditions. So here is overall, just a simple summary of the transcriptomics data in the spaghetti meat. So this is the more, interesting finding is that a differentially expressed genes found in the spaghetti meat and woody breast were overlapped together. And then in both spaghetti meat and woody breast, inflammation, immune responses are activated. And then connective tissue contents may be activated, increased, and tissue morphogenesis proliferation may be altered, and hypoxia and oxidative stress may be increased. In spaghetti meat only, the intestinal immune network for the IgA production may be increased, and then oxidative phosphorylation may be decreased. And woody breast only, but not in the spaghetti meat, showed the calcium and phagosome signaling pathways may be affected by that. And then the next is the metabolomics study with spaghetti meat. And this study also was published this year from the Yangzhou University, China. And in this study, muscle samples were collected at the industry facility, and RAS 308, 42-day-old male chickens were used. And then samples were collected right after chilling on ice. So the samples were collected less than 1 hour post-slaughter. And then about 18 samples for spaghetti meat and controls were used. And then metabolomics was conducted with liquid chromatography mass spectrometry. So in the phenotypic study and histological study and data processing and pathway analysis was conducted with the data. Actually, I'm not explain in detail for all these analysis part because we want to see what the findings from the omics study can be applied to use in this meat study. So as a result, the authors identified 35 differential metabolites, including 17 up and 18 down regulated based on the p-value less than 0.05. And this list is the up and down regulated metabolites list found in this metabolomics study, and also focusing on these increased 3 metabolites. Those are isotriethionine and 14,15-HETE, and then L-malic acid. And then increased metabolite, these 3 metabolites are may be implicated in the inflammation, oxidative stress, apoptosis, and muscle cell necrosis, and metabolism of the linoleic acid, arachidonic acid, phenylalanine, and histidine. And then this result is, consistent with the pathway analysis as shown in the next right-hand side of the table. And then on independent metabolomics, a study has been conducted in our groups. And then in this study, we used muscle samples. Muscle samples were collected at the commercial slaughterhouse. And 7-week-old male broiler chickens were used. And then each 6 samples for spaghetti meat, woody breast, and normal fillet were collected from cranial ventral area of the breast fillet at 24-hour post-mortem. And then metabolomics was conducted by the liquid chromatography mass spectrometry again. And yeah, again, is the data processing and pathway analysis were conducted and filtering process were conducted with this data. And then the total total of about more than 3,000 metabolites were detected in this assay, and then out of 3,000 metabolites, about 617 differential metabolites were detected, and they included about more than 200 up and then 342 down-regulated metabolites were detected. This is interestingly in this metabolomics study also showed that differential metabolites were shared between in the spaghetti meat and udi breast. So this table showed that it co-expressed differential metabolites in spaghetti meat and udi breast, and then this result also indicated again for the spaghetti meat may retain similar physiological alterations to the udi breast. And here is a quick summary of the metabolomics study. As you can see that in the second column, in the middle, center column, show there is a shared metabolites and then pathways found in the spaghetti meat and udi breast. And left column show there is the distinct alterations found in the spaghetti meat. Those are the downregulated NADH and downregulated amino acid, and then downregulated steroid hormone pathways. So last assay is the multi-omics analysis with the chicken spaghetti meat conditions. And we conducted with the multi-omics analysis with this spaghetti meat. In this study, muscle samples were collected from commercial slaughterhouse, and 7-week-old male broiler chickens were used. And then each A samples for the spaghetti meat and normal breast fillet were collected cranial ventral area at the 6-hour post-mortem timing. And then multi-omics was conducted by LC, liquid chromatography mass spectrometry. And then this is the example spectrum produced by LCMS. Earlier today, Dr. Quach already explained about the multi-omics analysis. And then this spectrum is exactly the same spectrum that Dr. Quach showed that. And then one assay can give us the three kind of the profiles. Those are total of the 2,593 molecules were identified from this multi-omics analysis. And then those molecules include 1903 proteins and about 500 lipids and about 181 compounds, and 3 electrolytes were included. Again, filtering process and then the quality control was processed. As a result, finally, we identified 185 differentially expressed differential abundant factors based on the false discovery rate less than 0.05 in the spaghetti meat. And then the differential factors including 151 proteins and 66 up and 85 down, and 16 metabolites, 3 up and 13 down, and 7 lipid species, 2 up and 15 down, and 1 electrolyte, potassium, was downregulated. So this table showed that in the list of the top 20 differential abundant molecules, so most of them, in here, we identified many of the factors, and the next question was that we wanted to. This result come from the multi-omics. So how about the target assay? So validation. We wanted to do this differential abundance. It's real. So some of the factors were subjected to the targeted assays, as we can see in here. NAD plus, it's not in here. NAD plus and the NAD plus was lowered abundance in the spaghetti meat condition in the multi-omics data, and then targeted assay also showed that is the lower in the spaghetti meat, and then p-value was around 0.05, and then unregulated triglyceride was consistent with multi-omics data and this validation study, and junctophyllin, JPH2, also showed a same trends of the regulation in multi-omics result and then validation assay. Only lactate concentration was lowered, slightly lowered in the spaghetti meat in the targeted assay, but it was not in the statistically significant levels. But even it's found in the multi-omics, the lactate levels was down in the statistically significant levels. So in this data, results show that is the multi-omics data could be reliable to predict of the pathway-wise or the muscle alteration of the mechanism pathways. So when we listed of the top 20 molecules showing highest fold change values, and then in spaghetti meat, interestingly, all these molecules were only proteins identified in this study. So when we look at the functional aspects of the proteins, and then those proteins may function in the extracellular matrix glycoproteins, and then sarcomere assembly, and then transcription factor, and the recruitment of the junctional proteins, and then collagen export, and the myosin heavy chains tied to the fast muscle types, and then carbohydrate metabolism and stress responses. Then when we look at the lower expression, so 20 molecules with the lowest fold change values in spaghetti meat, and then in this list we can find many of the lipid and metabolite species. Interestingly, top 5 metabolites and lipid are all the carnitine species. So the carnitines in muscle is known to function as a fatty acid uptake via beta oxidation, energy metabolism, and oxygen supply, and insulin sensitivity. So some of the altering pathway in those pathways are altered in spaghetti meat, and those features may be due to the lower level of the carnitine contents. And when we look at the lipid species only, and then interestingly, there are some increased abundance of the triglyceride and increased abundance of the sphingomyelin and ceramides. All these molecules are known to be associated with the insulin responses. So the spaghetti meat has the insulin resistant the features have it. So it's compared to the normal fillet, spaghetti meat has something altered mechanisms in the insulin resistance. In which the pathway analysis showed that in this differential abundance metabolized protein and lipid indicated that the alteration in the nonsense mediated decay pathway and metabolism of the RNA, and then decreased of the glucose metabolism and carbohydrate metabolism and glycolysis and so on. So here is a quick summary of the multi-omics analysis. So in this multi-omics result showed that the spaghetti meat breast fillet include increased nonsense-mediated decay pathway, indicating cellular stress response, and then increased triglyceride contents and decreased NAD and lactic acid, decreased carnitine species, and decreased fatty acid contents. So this slide is kind of the overall summaries and then possible next approaches. So various omics study provided some altered mechanisms and pathways, and those pathways may be overlapped in those studies. You can see that, for example, the inflammation pathways were identified from transcriptomics and metabolomics study. And then like oxidative stress pathway were identified as all 4 omics study, even though it was not indicated in the multi-omics result. NAD plus NADH imbalance was found in the metabolomics study and the multi-omics study. So our next question is how we can use this information identified from this omics study. So if we want to use, and then this information could be utilized to for the in vivo trial or the in vivo studies to prevent chicken breast myopathies. So if we can use this information for reducing spaghetti meat, and then the goal should become to maintain integrity of the muscle fiber bundles. So like if we want to use a nutritional intervention to prevent or to reduce the spaghetti meat incidence rates, so how about if we can increase the antioxidant content in the feed, like supplementing of the L-carnitine? And then how about supplementing with the NAD precursors in the feed? So those things we cannot say all these things could be causes, but if we can prevent to these the metabolic changes, prevent from the metabolic changes in the chicken breast muscle and the chicken physiological condition, could be this kind of metabolic disease and spaghetti meat incidence rates could be decreased. So that's my suggestion there. And then decrease the triglyceride is one of the approaches to reduce the spaghetti meat incidence rate. How about the opposite way? So if we want to develop for the study, if we want to develop the spaghetti meat induction models, so the goal is to decrease the integrity of the muscle fiber bundles. So in that case is how about increasing oxidative stress in the physiological condition, and then also how about increased fat contents in the feed. So we can detect that when maybe it could be worse, right, for the instance of the spaghetti meat. So I tried to summarize some of the very short take-home message here. So from this omics study, we learned that the physiological alterations found in the spaghetti meat are similar to those found in the woody breast. And then pathway and core molecules identified from this omics study may become the cause of the spaghetti meat and as well as the woody breast. And also these pathway and core molecules could become the target pathway to reduce and eliminate the myopathies. So suggested target pathways for the in vivo trial to reduce breast myopathies may include the modulation of the NAD and NADH balance and increase of the carnitines and reducing triglyceride concentration. That's all I prepared. Thank you so much. And if you have any questions, please, I'm happy to answer for that.